The first law of thermodynamics deals with the conservation of energy, mainly describing the change in internal energy of a system being equal to the heat in or out minus the work in or out of the system, and taking that change in internal energy and combining it with the change in potential energy and the change in kinetic energy is how you get the overall change in energy of a system. And in the next clip, I'll use my little friend Ruthie to help me demonstrate some changes in values of energy. This is Ruthie. She doesn't like being picked up very much. But when I pick her up a little bit higher, she has more potential energy than she did just now. When I'm holding her like this, she's a little bit warmer than me, so she's giving me a little bit of thermal energy until we'd come in equilibrium if we were inanimate objects. And then when I chase her around, she has a little bit more kinetic energy than she did before. With the help of my friend Ruthie, she demonstrated some changes in energy, and here are the equations that I mocked up to try to capture some of those changes in energy. The potential energy equation here, is it mass times acceleration times distance? So estimated her to weigh about 13 kilograms with gravity being 9.8 meters per second squared. And then I said that my chest height was about 1.5 meters off the ground, which gave us a change in potential energy of 191.1 joules. The kinetic energy change was Ke final minus Ke initial. I said that she started at 0 and got to about 2.5 meters per second. So that change in kinetic energy came out to about 40.6 joules. And then for our heat transfer, when I was holding on to her, I used the Fourier equation. And I got some values off of the internet, but it said that the skin length is about 0.0046 meters. The K value was 0.21 watts per meter Kelvin. And then I found that dogs and humans vary by about 2 degrees or 2.5 or 1.5 degrees Fahrenheit. Translating that into Kelvin and using the Fourier equation, I got that she transferred me about 15.9 joules of heat over a span of roughly 15 seconds.